Hey guys, Miss Gosling here. In this video, we're going to talk about the specific things needed to form stars. So by the end of the video, you will be able to explain, with reference to the Jean criterion, how stars are formed. So your understanding applications and skills are very straightforward. You need to understand what the Jean criterion is, and you need to be able to apply the Jean criterion to star formation. Now, one thing that is perhaps very nice to know is that this is entirely qualitative. You are not expected to do any calculations of what the Jean criterion should be. So let's start by talking about how stars are formed. One option, of course, is to be the standout in a boy band like Harry Styles or Justin Timberlake. But if we're talking about stars in the sky, stars form when we have a big cloud of gas and dust, and then something happens nearby. So maybe a meteor passes nearby. When this happens, the dust and gas starts to form clumps. Those clumps are heavier than the rest of the gas around it, and so the rest of the gas is drawn towards that clumps. Eventually, that clump is going to collapse in on itself, rotate and flatten into a disk, and it's rotating faster and faster and faster and faster and faster, pulling more and more material in on itself. And this is when it becomes a protostar. This is that protostar stage, right? We have a big hot cloud of gas that is rotating very, very, very quickly. And eventually, it heats itself up enough for hydrogen to start forming helium. We have nuclear fusion, we have a star. And at that point, we get a big flow of stuff from the star, and all the extra gas and dust gets blown away. You guys don't need to know that step. Okay, so that's the big picture about how stars are formed. But the thing is not every nebula is going to form a star, because not every nebula has enough mass in that initial clump to create a star. So the Jean criterion tells us the minimum mass needed for a nebula to become a star. We will only have the nebula collapse into a star if the mass of the clump, m, is bigger than the Jean mass, the Jean criterion. But where does the Jean criterion come from? So if we look at our big cloud of gas, we've got a bunch of these little gas molecules, and they are zipping around, moving all over the place, just living their best lives with lots and lots of kinetic energy, lots and lots of gas pressure. So when our gravitational disturbance happens and we get that first big clump, that star is only going to collapse if that clump gives the gas enough potential that the potential energy of the clump is bigger than the kinetic energy for the rest of the gas. If that happens, the gas again is going to collapse in on itself, and we are going to get a protostar and eventually a star. Now, down here, I did write the equation for what the Jean mass is. I don't expect you guys to know this, but it is important that you know about qualitatively what makes the Jean criteria bigger or smaller. So let's think. We know that gravitational potential energy, UG, is given by Gmm over R. And we know that kinetic energy is always 1/2 mv squared. So if I think about what makes UG bigger, if my gas is condensed together, then UG is big. If, however, I have a diffuse gas, so my gas is spread out over a lot of space, the distance from molecule to molecule is a lot larger, R is bigger, and UG is much smaller. So a condensed gas, a dense gas, is a lot more likely to meet the Jean criterion because it has a much smaller Jean criterion than a diffuse gas. Similarly, a hot gas is a lot less likely to meet the Jean criterion. So if we think about it, a gas that's cold has a very small velocity, right? Because temperature is related to the speed of the molecules in a gas. So if the temperature of the gas is small, then V is small, and the kinetic energy is small. Therefore, less potential energy is needed to overcome the kinetic energy, and the Jean criterion is much smaller. Similarly, if the gas is hot, the kinetic energy is much higher because the average speed of each gas molecule is higher. As a result, the Jean criterion is much harder to meet because the kinetic energy is big. So, to summarize, a dense, cold gas has a smaller Jean criterion mass than a hot diffuse gas. So a hot and diffuse gas has a much larger Jean mass and is therefore less likely to become a star. Go ahead and just draw a little star next to the dense cold gas because we're going to probably get a star from that, whereas my hot diffuse gas may never become a star and may just stay a nebula forever. Now, the big key thing I want to take away is if the mass of the gas cloud is greater than the Jean criterion mass, then UG will be bigger than K for the gas, and the star will collapse, and the gas will collapse and form a star. I want this exact statement to be somewhere in your notes, and I want this to be on a flashcard for you as well, with the other side being, describe the Jean criterion or something along those lines. Please make sure you have the specific phraseology in your brain all the time. So let's go ahead and do an example together. This is a 3-mark question. So when you're answering this question, make sure you make 3 distinct points. So here we go. The Great Nebula is located in Orion. Describe, using the Jean criterion, the necessary conditions for a nebula to form a star. So here, we have 3 marks. 2 of them should be about the necessary conditions. And that, of course, must reference the Jean criterion. So Jean, and I'm going to go ahead and write crit instead of criterion. The last statement should tell me that the nebula, some sort of therefore statement. So therefore, the gas will collapse in on itself to form a star. Typically, when we're asked to describe the conditions that will make something happen, the very last mark point is for telling me what will happen. So that is a really easy way to get 1 out of 3 points, even if you have no idea what the conditions are. So take a moment, write your answer to this question, and then when you are ready, start the video again, and we'll go through the mark scheme together. Okay, guys, hopefully you have an answer at this point. Take out a different colored pen and grade yourself. So here are the 3 marks from this mark scheme. First, the mass of the gas cloud has to be greater than the Jean mass. So that is your reference to the Jean criterion. The second statement that you'll get points here for are saying potential energy is greater, the gravitational potential energy is greater than the kinetic energy of the particles. And the third point is for saying that the cloud is going to collapse to form a protostar. So if you guys recall the statement that I mentioned 2 slides ago in green, that is the just about verbatim answer to this question. So that is why there is the method to my madness. This is why I want you to make sure that you have learned that statement, that you fully understand where it comes from, because this is what IB is looking for whenever they ask a Jean criterion question. So takeaways. First, the Jean criterion determines whether a cloud of gas will collapse and form a protostar. And second, just a reminder, protostars become stars when they begin nuclear fusion. So when they've gotten hot enough, they've started spinning quickly enough for their hydrogen to start fusing into helium. So there you have it, guys. Best of luck and happy learning.